Okay, so this is a continuation of what we learned last class, section 4, topic 5 and 6. So we're still talking about complex numbers. I'll call this video 2 when I post it on Edmodo. So if you recall, last lesson was on a C day, so we only got to go through a part of what's in this topic. Okay, so the rest of it's pretty short too. Alright, so imaginary numbers and real numbers together make up the set of complex numbers. We kind of touched on that yesterday. Imaginary numbers and real numbers together make up the set of complex numbers. So when we have A plus BI, whatever number is in A's position is the real part of the complex number, and whatever number is with I is the imaginary part of the complex number. Now, what we've been learning so far in our whole entire life, we've only had real parts. There has not been an imaginary part, okay? We've just been dealing with a real part. If you only have an imaginary part, there's no real part there, then that's called a pure imaginary number, okay? We'll see that sometimes. So let's write that down. If A is 0, comma, then you have a pure imaginary number. So obviously we wouldn't put like 0 plus 3i. If you just saw like 3i, then we just call it a pure imaginary number, okay? I'm not going to test you on that word or anything, just for your reference. Alright, so the first thing I'm going to show you how to do is how to add and subtract complex numbers. Adding and subtracting complex numbers. Example 1. Alright, so my first set of parentheses, I have 4 minus 3i plus negative 4 plus 3i. So just like if those i's were variables, which they're not just a variable, right? It represents an imaginary number, which is the square root of a negative. But just like if they were variables, I add these two groups of numbers together. If I distribute this positive sign, is it going to change anything in the second set of parentheses? No. So I'm just going to start by getting rid of my parentheses. To do so, I'll distribute the positive. So I have 4 minus 3i in the first set. Didn't have to distribute anything there. Positive times negative 4 is negative 4. Positive times positive 3i is positive 3i. Now when you add these together, or you combine like terms, you can only combine real parts together and then imaginary parts together. So my real parts are 4 and negative 4, right? So I'll just write those next to each other, 4 minus 4. And my imaginary parts, I've got a minus 3i and a positive 3i. So I haven't actually combined anything yet, I just wrote them together. So what's 4 minus 4? 0. What's negative 3i plus 3i? 0. What's my answer to this question? 0. So even though I started with a complex number which has a real part and imaginary part, what I resulted in is just a real number, okay? There's no imaginary part here, so this is just a real number. So just because I started and I had a complex number doesn't mean I'm going to end up with a complex number. Everything pretty much just canceled out. Anybody have any questions so far? Pretty easy? Okay. Example 2. All right, we have 5 minus 3i in the first set of parentheses minus negative 2 plus 4i in the second set of parentheses. Now before I can combine like terms, I've got to get rid of parentheses, meaning I've got to distribute this negative sign to every term in the second set of parentheses. When I distribute the negative, is that going to change anything in the parentheses? Yeah, when you multiply by a negative, it changes the sign, right? First set of parentheses, it's just 5 minus 3i, nothing to distribute, no exponents, nothing like that. Second set, negative times negative 2 is positive 2. Negative times positive 4i, negative 4i. So my real parts, what are my real parts? 5 and 2. So 5 plus 2 is 7. My imaginary parts, negative 3i minus 4i gives me negative 7i. Can I combine those? No, you cannot combine a real number and an imaginary number together. You have to write them separately. And you always put the real part first and the imaginary part second. We would say this is in A plus BI form. And that's how you write it. When you have a complex number, A plus BI form means real part and then imaginary part. Pretty tough stuff so far. Not really. We have a question? Example 3. 8 plus 6i, close parentheses, minus, open parentheses, 8 minus 6i. Y'all do this one on your own and let me know what you get. Or raise your hand when you've got an answer. Got an answer? Millie, what'd you get? 12i. 12i. Did anybody else get 12i? Anybody get something different? 12i is correct. So when I distribute the negative, I have 8 plus 6i. Negative times positive 8 is negative 8. Negative times negative 6i is positive 6i. So my real parts, 8 minus 8 is 0. And positive 6i plus 6i is plus 12i, right? So we wouldn't write the plus 0 plus 12i, so our answer is just 12i. And that's what I got too. So what did we say on the previous page? If your a is 0, what's it called? Pure imaginary number. So this would be an example of a pure imaginary number. All right, so y'all cool with adding and subtracting complex numbers? All right, easy stuff. So now let's multiply complex numbers. Pretty simple as well. There's only one little tricky part that we have to remember. Multiplying complex numbers. And we wrote in our notes last class that there was an important part that we need to remember, and I want to also include that here. Remember, I squared equals -1. So whenever you see an I squared, you can't leave that, okay? You always replace it with -1. Always replace I squared with -1. So example 4, we have 3i times the quantity of -5 plus 2i. So I'm not adding 3i to the parentheses or subtracting it. There's no sign in between 3i and the parentheses, so we know that means we have to distribute. All right, so what is 3i times -5, do you think? -15i. What is 3i times positive 2i? Positive 6i squared. Are those like terms? No. And what did I just tell you above? Right, whenever I see an I square, I've got to replace it with -1. So that means -15i plus, instead of 6i squared, it would be 6 times -1, because isn't 6i squared mean 6 times I squared? So it's 6 times -1, not 6 minus 1. So that gives me -15i minus 6. So now where we did have that imaginary number there, when we replaced I squared with -1, it turned into a real number, right? So can I combine -15i minus 6? No? Is there anything else I can do?
Write it in
BI form, right. I need to write the real number on the left side and the imaginary on the right side. So just want to make sure it's in A plus BI form. You might have a question on that? Anybody still writing? All right, example 5. We have in our first set of parentheses 4 minus 3i. Second set of parentheses, -1 minus 2i. All right, so now I have a binomial times a binomial. So we know we have to distribute every term in the first set of parentheses by every term in the second set of parentheses, okay? Of course, I'm going to be all color coordinated about this. So let's start with the first term times the first term. Gives me what? -4. The outer term times the outer term gives me -8i. The inner term times the inner term, -3i times -1, +3i. And my last term times my last term, -3i times -2i, plus 6i squared. Okay, so we have some like terms that we can combine. We also have an I squared. Okay, so let me just take this step by step. So -4 is my only real number right now. I don't have anything to combine it with. I'm just going to bring it down, right? -8i and +3i, I'm not multiplying those together. I'm adding them. They're like terms. I can combine them. What do I get? -5i, exactly. I couldn't either.
What are we gonna do? Like, we need to storm the district office and be like, this is not okay.
I hear you. I'm recording.
I think I'm gonna be
Yep, I hear you.
I'm gonna email Will College.
Please do. Please, because I'm very frustrated as well. Sorry about that. Okay, so plus 6i squared is +6 times -1, right? So we replace I squared with -1. Okay, don't forget to do that. It's not a quadratic. When you have that imaginary number, it's not like we have ax squared plus bx plus c. Okay? All right. So now I have, and I know y'all can do this in less steps, but you know on my notes. So I have -4 plus 5i, and +6 times -1 is -6.
Wait, how'd you get plus 5i?
Oh, yeah. No. Yes, thank you. It should be -5i. And then -6. So let's change that. Make sure you change it on your paper. Nope. Have to come back and fix that when the whiteout dries. Okay, anything else I can do?
Combine -4 and -6.
Right, so now I have those two real parts, right? So I can combine those. What is -4 minus 6? -10, and then that sign was up minus 5i. Anything else I can do? No, now it is in a plus bi form. All like terms are combined. We don't have any I squared. We're good to go. That makes sense? Okay, I have one more example. Y'all can try it on your own. Come back and fix my minus sign here in a minute. So example 6. We have, first set of parentheses, -6 plus I. Second set of parentheses, -6 minus I. No, we're not factoring, we're doing the same thing. Multiplying, distributing. So work this one on your own, please. Haley, what'd you get for the answer? 37. Did anybody else get 37? Anybody get anything different? What'd you get? Oh, the answer is 37. Yes, it's 37. All right, so let me work this out. What is negative 6 times negative 6? Positive 36. Negative 6 times negative I? Positive 6I. Positive I times negative 6? Negative 6I. And positive I times negative I? Negative I squared. So you gotta be careful right here. Minus I squared. And we know we're gonna be subtracting a negative 1, right? As you're subtracting and you replace I squared with I. So bring down your 36. What's positive 6I minus 6I? 0, right? They cancel, or I'll write plus 0 now because I have all the room. Okay, so basically I have 36 plus 0 is 36, and a minus a negative becomes a positive 1. And so that gives me 37. So now, even though we started with complex numbers, the result is just a real number. We don't have an imaginary part, so we do not have an imaginary answer. Okay? Y'all cool with this? Ready to do the classwork assignment that'll be due today? Awesome.